Welcome my students and viewers. Today's class is a kind of demo class, as from mid-March we are going to start a separate online classes for UGC, NET, GATE and all these courses. And in online class we can just linger the class for an hour or even more than that. But in such videos, it's not feasible to solve more questions or a bulk of questions because it's a very time-taking job. So till we don't start the online classes, I'm just solving few questions in this class and rest questions because as of now I do have questions around 600 questions. All are numerical questions of macro, micro, growth, finance, trade, relating to all rather all the branches of economics. And that much of questions cannot be solved in such videos unless and until I take the online classes. So all those questions I'll be solving in online classes, and the students have started for their registrations for those classes. So before that class starts, I'm going to solve few questions which are numerical in nature, and those questions are related to all branches of economics. So this is all, and today I'll be solving 8 to 10 questions, and these are the first two questions. So a discriminating monopoly has E1 minus 3, that is the price elasticity in one market and price elasticity 4 in another market, in two markets. Now, if price in one market is 50, find price in another market. So just for solving this, you have to keep yourself that P1 by P2 is 1 minus 1 by E2 by 1 minus 1 by E1. This equality will just solve the answers, and P1 is given as 50. So this is 50 by P2, 1 minus 1 by E2, that is 1 by 4, and 1 minus 1 by 3, that is 3 by 4, and 2 by 3, so 3 by 4 and 3 by 4 and 3 by 2, that is 9 by 8. So now the value of P1, so 50 by P2 is 9 by 8, so 400 is 9 P2, hence P2 is 400 by 9, so approximately 45. This is the answer. So this will be the answer. If P1 is 50 and these two elasticities are given, this will be the answer. Now this question, second one, this tells that we have 4 demand functions, and out of these 4 demand functions we have to identify that which demand functions, which one of these 4 signifies a relation of substitute goods. Here are two goods, X and Y, and whose prices are Px and Py. So we have to identify that which one is the demand function of, right. So substitute goods are, now a few 2-3 videos back, one special video I had made for nature of goods. So if X and Y are two goods, it's Px and Py, and Qx is a function of Px and Py, then if delta Qx by delta Py is positive, then X and Y are substitutes. And if delta Qx by delta Py is negative, X and Y are complements. Now delta Qx by delta Py plus 5, so definitely this is for substitute goods, and all rest 3 demand functions, delta Qx by delta Py minus 5, that is complementary goods. This is once again complementary goods, and this one once again delta Qx or delta Py minus 1, so this is complementary goods. So This one stands for substitute goods, and B, C and D, because in these three cases delta X by delta Py is negative, B, C and D, and delta rather Qx, and delta Qx by delta Py is positive A, and this is for substitute goods. Now we have two questions. This one is, which of the following cost functions signifies the cost function of a natural monopolist, right? Here we are given 5 TC functions, and out of these 5 TC functions we have to identify that which TC function relates to a natural monopolist. Now what is natural monopolist? So in natural monopoly, production activity allows technology to reduce average cost by expanding output. Yes, that is the very concept of natural monopolist. So average cost is inversely proportional to the output. In natural monopoly, what happens? A natural monopolist uses that production or such production activity where, on account of the use of technology, average cost diminishes as the level of output is increased. So there is an inverse relation between average cost and output. If by expanding output average cost decreases, then it is a feature of a natural monopoly. Now here we have 5 TC. We shall calculate average cost for all TC, and only that TC will relate to the natural monopoly, whose AC would be inversely proportional to output. So number A, TC is 15Q, so AC is TC by Q, that is 15Q by Q, that is 15. No, this is not the answer. Now B, TC is 15Q square. So AC is 15Q square by Q, 15Q, directly proportional. So this is not the answer. Third is TC 15Q plus 15Q square, 15Q plus 15Q square. So AC is TC by Q, 15 plus 15Q. So AC is directly proportional to output. So C is also not the answer. Now D is TC is 15Q plus 15Q square plus 15Q cube. So AC TC by Q, that is 15 plus 15 cube plus 15Q square. AC directly proportional, as Q increases AC increases. So that is also not the answer. And number E, TC is 15 Q to the power 0.5 15 Q to the power 0.5. So AC is TC by Q, 15 Q to the power 0.5 divided by Q, and that is 15 by Q. Yes. So now for this cost function, average cost and output are inversely related. If output increases, average cost diminishes. So this is the total cost function of a natural monopolist. All above 4 are not. Now this question number 4, standard cubic total cost function. Now for deriving or for identifying the cost function, if you go to the theoretical part, we have total cost function as this is total cost, this is total fixed cost, and this is total variable cost. Now this is total cost function, and it has two parts, concave part and convex part, and this is the point of inflection for this total cost function. Now such curve which have the both segment, one segment as concave and another segment as convex, has to be a cubic. So the algebraic function just corresponding to this TC would be a cubic function. All are the cubic functions. So, and standard form of a cubic function is ax cube plus bx square plus cx plus d. Now, there must be some particular relationship between these coefficients a, b and c. Only then we can identify that which one is. So, out of these four, this is the answer, because the standard cubic function happens to be ax cube minus bx square plus cx plus d, and this condition must be fulfilled, that 3ac must be greater than b square. Only then it behaves ideally, and this is an ideal cubic cost function. Ideal cubic cost function. So this is the answer. Yes, question number 5 says that for a U-shaped cost curve, level of output is 5, AC is 20 and MC is 12. Then it has been asked that find the slope of AC. Now look, for such sum there is a particular relationship in economics which has to be kept in mind. This is average cost. This is marginal cost. Now let this output. Now for this output, this is MC, say MC. So AX is MC for this level of output, and for the same level of output, BX is AC. So for OX level of production, for the monopolist or for any producer, AX is the marginal cost and BX is the average cost. Now at this point B, slope of AC, that is DAC by DX. Now we do have a definite relationship between slope of AC, average cost, marginal cost and the level of output, and this relation says slope of AC, that is DAC by DX, is MC minus AC and divided by X. Yes, this relation will be used right here. So question number 5, X is 5, AC is 20, MC is 12. Then find the slope of AC. So DAC by DX minus 8 by 5 minus 1.6. So definitely this output, that is 5, is less than the minimum. So this must be here. That's why slope has been negative, because left to the minima slope is negative and right to the minima slope is positive. So obviously this says that this output is less than the minimum output, and at this output slope happens to be negative and this slope is minus 1.6. Number 6. Numbers for a U-shaped cost curve. X is 10. Slope of AC is 6, MC is 14, then AC has been asked. So 60 is 14 minus AC. So AC is 60 minus 60 plus 14 minus 46. So this data is insufficient. Definitely data is somewhere insufficient because AC is turning out to be negative, which should not be negative. That AC has to be positive, or whether it to the right of X minima or to the left of minima, that has to be positive, but this turns out to be negative. So there is some data insufficiency in this, some data insufficient. Such type of questions are also being asked in exam. Number 7, when the slope of AC is 3, AC exceeds MC by 11. Yes, so 11, because this is a difference between MC and AC. So AC exceeds MC 11. So definitely this will be a minus 11, and output MC by 11 is, find the slope of AC is 3, and so this has been output has been asked. So output is 11 by 3 and 3.7. So for solving such sums, this relation should be kept in memory, that this is a relation between average cost, marginal cost, and the level of output. This is what it says. Now, question number 8. This says, we have a total cost function, and it has been asked that for which value of X AC is rising and for which value of X AC is falling. Now this is the total cost function. Corresponding to this total cost function, we shall calculate the average cost function, and when we find the average cost function, we minimize this average cost. Probably it would be 15, and if average cost is minimum at 15, then we say that average cost is falling when X is less than 15, and average cost is rising when X is greater than 15. So for answering this question, AC has to be minimized. AC is to be minimized. Now, corresponding to this TC, AC would be TC by X, that is X square by 10 minus 3X plus 50. Now this AC has to be minimized. So for minimum, dAC by dx 0, that is 2x by 10 minus 30, that is 2x by 10 is 3. So 2x is 30 and x is 15. Yes, so x is 15. So our answer would be that AC is falling when x is less than 15, and AC is rising when x is greater than 15. So for such sums, the function has to be either minimized or maximized. Only then we can say that for which value of x that particular curve is rising or falling. So this answer would be this one. Well, students, in this class I have explained 8 questions, because the explaining the question, it takes time, because I have to touch every nook and corner of the question, and whatever the hidden concept behind the question, that too I have to explain in the class. So definitely it takes time. So larger number of questions cannot be solved in such videos. That could only be done when just we come on the online platform. There we shall have no constraint of time, and we shall be freely using time to solve our course as much as we can. So for today's class, I have solved these 8 questions. All were numericals and all were informative. So this is all for today. We are coming in the again next class. There I shall be just solving much more questions than this. And this is all for today. Thanks. Best of luck.